All right. So you're going to get the intermediate value theorem or the mean value theorem. There's a lot of different names that you're going to get this year. The one we have here is the intermediate value theorem, and you might want to say 4 continuous functions. Might be helpful to add on there. If you actually go and try and read this paragraph, it can be somewhat confusing unless you take it bit by bit. And that's something that you might want to start trying to figure out on your own, because when you go on, that stuff might get explained, it might not. Right? And so basically it's saying we have some function that's y equals f of x. So if I put some x value into the function as an input, I get out a y value as an output. You agree with that? That's kind of what it's saying. I put some x value in, I get some y value in the end. It says if it is continuous on a closed interval from a to b, notice the brackets are on there. What does that mean again? Including a and b, yeah. It ends, true. Takes on every value between f of a and f of b. So are these x values that we're talking about here or y values? Those are y values, because f of x spits out a y value. So they just changed x to a and b. So f of a and f of b are going to be y values. In other words, there is some y value in between those two y values. Okay? And they're saying that that y value will have some x value that has to be between the two x values that we have. A picture is a lot easier. Do you agree that we have f of a and f of b over here? So you could have looked here and seen that they were y values. All right? So you agree a, b, and c are x values. So if I was at a, I would substitute it into the function, and it would basically give me that y value. They would kind of come together and give me that point. Right? I just have dashed lines so you could see it. And same thing with b. I could substitute b into the function, and f of b is right there. So do you agree that if I substitute those in, I get basically an ordered pair, right? And do you agree that the graph I have given you is continuous on a to b, right? Do we know what happens left of a? No. Do we care? Not really. Not on this problem. Do we know what happens to the right of b? No. But again, for right now, yeah, we don't care. It just would be some closed interval. And what they're saying is that if I give you a y, do you agree that the y sub 0 that I chose here is between the two y values that we ended up with? What it's really saying is then there has to be at least one x value in between those two x values that gives you that ordered pair, is really all it's saying, if it's continuous. Could it give you more than one? Yes. But it has to at least give you one. Do you agree with that now? That if that y value is between those two y values, there's got to be an x value between the two x values that gives me that ordered pair. Could I change that y value and say, put the y value up here? Yeah, and if you go across, is there some x value that gives you that? There is. There's at least one. It has to happen. Now then people historically ask, well, what about a line? I think I got one in here. Does it still work for just a line? Do you think it does? And that's what your second example there is for. If I gave you this, I still get some y value, agreed? And does it have to be increasing like the two that I gave you are? Both of these are increasing. It doesn't have to be. They could be decreasing. And then there's the other y value, right? Because we're from a to b, so we go find those y values. And then pick a y value, something in between. Is the y value that I have chosen, is it in between the two y values we ended up with? It is. And do you agree that if I go across, apparently it's not there, but if I go across, there is going to be some value down there that makes that happen. At least one. Now granted, could the graph do something like this from a to b? Could that happen? And does it still give me f of a, right? Because that's putting a in, and f of b, right? You don't have to add this one in if you don't want. But do you agree I could pick any y value in between there? And is there at least one x value that gives me that? Yeah, in fact, how many are there? There's 1, 2, 3, there's 5 of them, right? But there's at least one, right? And that's really what it's saying. And this is only going to happen if that function happens to be continuous. If it's not, we don't know. Maybe, maybe not. Okay. Any questions so far? Now, of course, seeing you all have these graphs, it's going to go so much faster. So, graph each of the following functions to determine if each is continuous. Wow, that's some really good English I've got in there. On the given interval. So that's what these little things are, 1 to 5, 3 to 9, all that stuff. Those are the intervals that we're concerned about. If it is not continuous, then determine the value, or if it is, excuse me, then determine the value of C guaranteed by the intermediate value theorem for the given value of Y. So C is actually the X value, basically, is what it's asking for. So X squared plus 2, what'd you get when you graphed it? Yeah, I started you off with an easy one, right? It's a parent graph, and all you got to do is move it up 2. But I did tell you on the other day to make sure you get accurate graphs because we're going to want to take a look at it. And I think mine's fairly accurate. And what interval am I concerned? I'm not worried about the whole graph. I'm only concerned about 1 to 5. So what I normally do, and you don't have to, is I say, okay, I'm concerned about from here. Well, there's 1, 2, 3, 4, there, right? That's what I'm concerned about. So the first thing we should do to see if we can even use the intermediate value theorem is it continuous? So if I go up here, do I get some Y value? Yep. If I go up way up in here somewhere, do I get some Y value? Is it continuous on that interval? In fact, this graph is continuous everywhere, right? So that was kind of a no-brainer in this one. So it is continuous from 1 to 5. Agreed? What they're saying is that there is a Y value of 4 out there somewhere then. How do we know that? Because what's the Y value right here? The Y value on this one is, well, here, I'll do it this way, 3. The Y value on the other one is 27. I just substituted it in for 5. Right? These are the Y values. So do you agree the Y value I asked you for is between the two Y values? Because the points are 1, 3, and 5, 27. You agree these are the X values? And I asked you these are the Y values? I asked you for a Y value of 4. So should it happen? Should it be in there? You told me continuous. It should at least happen once. So let's find out. Go to a Y value of 1, 2, 3, 4. There it is. Go over. Do you agree it's there? Okay. Now this one's a little harder. So we agree it's there. But then how do we go about necessarily solving for that one? Because this one's not very nice. It's not just 1. What do you mean substitute? Yeah. Aren't we saying Y has to be 4? So to make that Y value right there, 4, and you're only left with X, right? So 4 equals X squared plus 2. So it's 2 equals X squared. Now technically, at this point, we would do this, correct? But technically, just algebraically, correct? But how come that right there is not the answer to this question? Yes? Right, we're only looking from 1 to 5. Are both of those answers from 1 to 5? No, so we just go ahead and we say, go away. Yes? Right, that's like your A and B from the intermediate value theorem itself. It's saying only look from this X value to this X value. You have to check the Y values because I might be sneaky later and ask you to check a Y value that's not even between the two Y values that we're talking about. Which is why I went and checked. It's 3 and 27. Is 4 actually between there? Yeah. So should I have asked you for a Y value of -2? No, I can. You know, it's not in there. I could have, right? But it's the intermediate value theorem is not going to help me with that because it's not between the Y values. I could have asked you for 26. Okay. I figured writing it as ordered pairs was going to be helpful. Well, what'd you find out when you graphed this one? Okay, I'm not sure funny looking one is what I was looking for, but Ed has asymptotes, and where are they? What equals -3? Which asymptote? X equals or Y equals? So vertical, okay. So X equals -3, did you say? Or +3? Well, let's find out. Oh, there it is. There is most definitely a hole. I was looking for that first, but it's at. So we know there's a hole at. And how'd you know that? Yeah, factors crossed off. And once it crossed off, I believe you were left with something like this, right? So remaining was y equals 4x over x plus 3. Is that right? And I'll explain why, because you agree I've written these things quite a bit so far. So what else do you see if you're looking down, say, there? Well, we already got that. But then if you look at the whole thing, it's for what? 4 for what? Horizontal. So it's what equals 4? Y equals 4. 1, 2, 3, 4. And there it is. Now, the reason I like to always write this remaining is especially for holes, because it tells me where it is. I know the x value of the hole. How can you find the y value of the hole and be exact? Yeah, put it in here, what's left over. How come I can't put it in the original? Yeah, you're going to get a 0, most specifically in the, it's going to be both because you crossed it off, but the denominator is the one that causes the problem. So put 2 in there, so it's a hole at 2 comma, well, be 8 over 8/5. Okay. So you want to try and get that as close as you can. Well, what'd you find out? I'm hoping you went to your table of your TI-83 at this point and got some points in there. I did. I got -9, +6. 1, 2, 3, 4, 5. That was one of the points I got. -7, -7. And -5, 10. Those are some of the points I got. And it did something like that. Agreed? Now, if I didn't ask you just to graph it specifically, I'll be honest, if I was given this particular problem, I wouldn't have even graphed that part I just graphed. Why? What do you mean it's got to be positive? Yeah, it's got to be 3 to 9. So I don't really care what happens over there right now. Not really. All right. All right. So then we go over here and we get some points, and I got let's see, -2, -8. I got as a point, and I got -1, -2, and 0, 0, 1, 1. And then you try, if you saw 2 on your calculator, it said error, right? It didn't tell you 8/5, right? It just said error. Didn't know what to do. All right, and then 3, 2, right? And 9, 3. Do you agree that's in general? Now, we're going to want to put that hole in there at some point. Yeah, might as well do it now. Yeah. So basically it's 2, 1 and 3/5 or 1.6, right? So 2, 1, 2, right there. Oh. Sorry. We'll fix it. Now, somebody just a second ago said, well, do we really care or something like that? And really in this problem, we do care that there's a hole. But where this particular hole is, do we care? Why? It's not 3 to 6 or 3 to 9, right? So it's 3 to 9. So if we check the intermediate value theorem, can we actually apply it? Is it continuous where I'm looking? Yes, it is. So then we can try to apply it. What if I would have said 0 to 9? No, you can't apply it then because it's not continuous, all right? Because of a discontinuity known as a hole, which is also known as a removable discontinuity, all right? So what I would like to do is first then it's 3 comma what and 9 comma what? Well, it was 9 comma 3 and 3 comma 2. So is the y value I'm asking for legit? It's between the two y values, exactly. So is it something we can find? Yes, it is. And so here's 2.5. Do you agree with that? So somewhere along the way, that had to have happened. Right? Yes. I looked over there, actually. I kind of cheated, but what you could do is just put 3 in here. Yeah, but I looked and I already graphed them, so I knew it was 3, 2 because I just graphed it, and 9, 3 because I just graphed it. Yeah, so that's how I knew. And 2.5 was in between the y values. So I know my answer has had to be between 3 and 9 somewhere, and unfortunately there is only one way to get exact unless you had that table sitting right there and you went out to the halves, which would have been a smart thing to do, but... So, put 2.5 in for y. How are you going to solve that? Now we're working on your algebra skills. What's that? What does it say?
4 x cubed minus 8x divided by x squared plus x minus 6. Long division.
No, I would not do long division on that one. You could do that. Because did I really have to set the original equal to 2.5? Oh, now we got people starting to think. All right. It is the safe thing to do. You're right. Well, we could try that. Now, where'd that come from? Did I just make that up? Did that just feel like a good thing to do? Just put that up there, 4x over x plus 3? Yeah, that must have been it, right? Well, this is what was left over once you took the whole out. So how are we going to deal with this x plus 3 on the bottom? Multiply it over. So can I distribute the 2.5 while it's just kind of sitting there? Is that okay? And what is then the 3 times 2.5? If you had $2.50 and 3 people gave you $2.50, you know, and you got $7.50, right? Not with a whole lot of confidence, no. When you go $7.50, you were trailing off. And I'm pretty sure there was a 9er in there. 7.5 equals, well, this is a little bit harder, but you can do that. Okay, so most of us can do that. You think it does? X equals? Yeah, you could have gone to your, that's what I would have done. Gone to the table and gone up by a half. Yes? Yep. Because you'll be given the x, like the 3 and the 9, but I might be tricky and say ask you for, well, let's face it, would a y value of -3 work in this problem overall? Is there a y value of -3 somewhere? There is. But is it between 3 and 9 for x values? It's not. Okay, so that's why you have to be careful, and that's why you should check. Okay, what'd you get here? A line with a hole. Yeah, somewhere. -2, -4 is where your hole is. And so we're going 1 to 6. So 1, 2, 3, 4, 5, 6. So 1 comma, -1 and 6 comma, looking at my graph. 1 comma -1 is that point right there. 6 comma, I'm guessing 4. Or of course you could substitute them in here and see what you get. Or look on your table of your calculators. So am I asking for a y value? Well, first off, is it continuous on the interval I asked you? Yes, it is. Is the y value I'm asking for in between the 2 y values that we actually have? Yes, it is. And so then we can actually take care of this problem. Again, it's a lot quicker to take what was remaining. Y equals x minus 2. It's way easier to substitute it in here because that's what was remaining. And so basically take that value of 2 and put it right there. X is 4. Or if in this one, you could probably trust your graph fairly well, right? Here's a y value of 2. Right? Any questions on that one? That one's pretty straightforward once you got the graph. And the last one. What'd you find out here? You got a slant asymptote and a vertical at x equals 1, yep. Where was the slant? Y equals x minus 1. Yeah, it's kind of more on the outsides. Once again, I would go to the table of the calculator, which is what the note said for you to do. And so 2, 0 I got as a point. 0, 0 over on the other side. And yeah, good enough. Okay, so it wouldn't do that, but you get the idea. Something like that. So 2 to 5. Is 2 to 5 okay? Are you sure? So 2, 3, 4, 5. Yep. Obviously 0 to 3. Good range on this one. Good interval. No, there's discontinuities. You can't use it. And so it is 2 comma 0 and 5 comma. That one's a little harder. But let's face it, the only thing we need to know is it bigger than 1.5? It's more like a 2.5, right? Just based on our graph, do you see how it's like 2 point something, right? 2.5? Why was I just concerned if it was bigger than 1.5? Yeah, because it's actually in between, right? And so if we wanted to solve this one, what happened? I think we're good. Yeah, it's 3.75. That's all right. So, but anyways, it's in between. And so you do all that work, and you find out that it's actually a nice number that I chose. Or if you looked at your table, you happen to see that one sitting somewhere. Because that's the actual answer for that one? No. That's not even rounding down. What is what I just wrote? If you put in 3, you get 1.5.
Oh, we just tried that math. Yeah, you did Hannah math. Shame.
Well, I figured most of you had the tables anyway, so you were good to go.
Yeah, I had the table too.
Yes? What'd you figure out?
My answer is wrong though, but if I wouldn't know to put 3 in or what to make my table,
Oh, how to solve it otherwise? Sure. So we want y to be right? I would multiply this up, so it's 1.5x minus 1.5, right? At this point, you would have to decide if you want to deal with the 1.5s or not. What you could do is just go ahead and multiply everything by, how would you get rid of 1.5? What's an easy way to get rid of the decimal? Multiply by 2, but you have to multiply everything by 2. So that would make this
3.
right? You could use the decimals, but I'd get rid of them. And subtract 3x. I got positive over there. So negative 3 equals 2x squared minus 7x. Can I just put the plus 3 over there? Is everybody going to?
Is this that one thing?
And now it equals 0, key number factor. And only take the answer that's 2 to 5. Right, but you can't do pants because the 2 out front. You have to break. You actually you have to do pants because the 2's out front. No. Oh. Well, we're done with the notes. I'll do the key number factoring on the side of the board.